Millions of people eat them every single day. They twist them, dunk them, pull them apart without thinking twice. It feels simple, familiar, automatic. But almost no one asks the real question. What does it actually take to make this one cookie exactly the same every single time? Because an Oreo isn't just a snack, it's a system. A system built on controlled chemistry, industrial precision, and decisions engineered down to microscopic detail. Every bite you take has already been calculated. The crunch, the sweetness, the snap, the way the cream spreads, none of it is accidental. And once you understand how it's made, you don't see it the same way again. The illusion of simplicity. The Oreo was first introduced in 1912. At its core, the idea was simple: 2 chocolate wafers with a sweet cream filling in between. Over a century later, that idea hasn't changed much, but the process behind it has. Because making a cookie at home is easy. Making billions of identical cookies across factories, countries, and climates is something entirely different. At that scale, even the smallest variation becomes a problem. A slight change in temperature, a minor shift in ingredient ratios, a delay of a few seconds. Any of those can ruin an entire batch. So the real challenge isn't just making Oreos, it's making them identical. Ingredients. Simple on paper, complex in reality. On paper, the ingredients look basic: flour, sugar, cocoa, fat, and leavening agents. But in industrial production, each ingredient becomes a controlled variable. Take flour. Its protein content must be precise. Too high and the cookie becomes tough. Too low and it falls apart. Then there's cocoa, the defining ingredient. Oreos use alkalized cocoa, also known as Dutch processed cocoa. This process reduces acidity, deepens color, and creates that smooth signature flavor. Without it, Oreos wouldn't taste like Oreos. Even the fat plays a role. It controls texture, shelf life, and how the cookie interacts with the cream. Nothing is random. Every ingredient is selected for how it behaves, not just how it tastes. The dough, engineered, not baked. Once measured, the ingredients move into mixing. But this isn't like baking at home. Everything follows strict ratios and sequence. Dry ingredients first, to ensure even distribution. Then oil to bind everything together, then water to form the structure. The result is not soft cookie dough, it's dense, controlled, engineered. This dough isn't made for creativity, it's made for precision. Temperature, the hidden control. After mixing, the dough is cooled. This step is critical. Warm dough is unstable. It stretches, cracks, and deforms under pressure. That kind of unpredictability can destroy consistency across thousands of cookies. So manufacturers bring the dough to a precise temperature, sometimes using rapid cooling systems. This ensures the dough behaves exactly the same during shaping, because consistency doesn't start in the oven, it starts here. Shaping, where identity begins. The dough is then pressed into perfectly identical discs. At the same time, the Oreo pattern is stamped onto the surface. Most people think this pattern is just branding. It's not. It helps control how the cookie bakes. It distributes heat evenly. It even affects how the cookie breaks when you bite into it. Every detail, the thickness, the diameter, the pattern depth, is calculated. Thousands of cookies are formed every minute, and every single one is nearly identical. Baking, the narrow margin. The shaped cookies enter industrial ovens at around 180 degrees Celsius. They stay there for about 10 minutes. But here's the problem. The margin for error is extremely small, too hot, and the cookies burn or become too brittle, too cool, and they stay soft, ruining the signature crunch. Even airflow inside the oven is controlled. Sensors constantly adjust heat and timing in real time. Because once a cookie is baked wrong, there's no fixing it. Cooling, perfection, filtering. After baking, the cookies are rapidly cooled. This locks in their structure and prevents further cooking. But this stage also acts as a filter. Automated systems scan every cookie. Cracks, color differences, shape issues, anything slightly off is removed. Only perfect wafers move forward. Not good enough. Perfect. The cream. The real experience. While the wafers cool, the cream filling is prepared. This is where most of the sweetness comes from. But more importantly, it's where balance is created. The cream is made from sugar, fat, and flavoring, but its texture is everything. It must be soft enough to bite through, but firm enough to hold shape. It must spread under pressure, but not collapse. Too soft, messy. Too hard, unpleasant. So the cream is engineered with precision, down to mixing speed, temperature, and consistency, because the cream isn't just filling, it's structure, assembly, precision at speed. Now everything comes together. A measured amount of cream is placed onto one wafer. A second wafer is added on top, thousands of times per minute. Machines align each cookie perfectly. Pressure is carefully controlled. Too much, and the cookie breaks. Too little, and the cream doesn't spread correctly. What you get is something simple, but only on the surface. Packaging, protecting perfection. After the cookies are carefully baked and cooled, the next crucial step is packaging. This stage is far more than a finishing touch. It is a deliberate process designed to protect both flavor and texture. The cookies are first sorted to ensure uniformity, then neatly stacked to maximize space and maintain their shape. Once arranged, they are sealed in protective wrappers that act as a barrier against air and moisture. Without this safeguard, the crispness could fade and the softness could turn stale in a matter of hours. Packaging is therefore not simply about presentation. It is a science of preservation. Even the way cookies are positioned inside the pack is intentional, preventing breakage and ensuring consistency. Every detail, from the seal to the spacing, works together to deliver a perfect experience. The goal is simple yet vital. When you open the package, the cookies should look inviting, feel fresh, and taste exactly as intended. That moment of enjoyment is the result of careful planning, where protection and presentation merge seamlessly. In essence, packaging transforms cookies from a product into a promise, one of freshness, quality, and satisfaction with every bite. The global system. From there, Oreos enter a massive distribution network. They travel across cities, countries, and continents. And here's the most important part. No matter where you are, the Oreo tastes the same. That's the real achievement. Not just making cookies, but controlling a global system so precisely that variation disappears. The bigger truth. An Oreo is far more than a simple combination of flour, sugar, and cocoa. At its core, it represents precision, control, and engineering. Every aspect of its creation is carefully designed to eliminate randomness. From the sourcing of ingredients to the exact ratios used in the recipe, nothing is left to chance. The process is a system, one that ensures each cookie tastes, feels, and looks the same, no matter where or when you open a pack. Even packaging plays a role in this pursuit of perfection, protecting texture and freshness while reinforcing consistency. The Oreo is not just a snack. It is a symbol of reliability, crafted through countless deliberate choices. Each bite reflects a promise that the experience will be identical, predictable, and satisfying. In essence, Oreo is consistency made edible, a product engineered to deliver the same joy every single time. Final thought. So next time you twist one open, ask yourself something simple. Are you eating a cookie? Or are you experiencing one of the most controlled food systems ever created? Because once you understand what goes into it, it's no longer just a snack. It's precision you can taste. Outro. If you enjoy breaking down everyday things and discovering the systems behind them, make sure to like and subscribe. Because sometimes, the most ordinary things in your kitchen are the most engineered.